Hi, I'm Tom, coming to you from the International Academy for Sourdough Baking Arts and Sciences of Cleveland, Ohio, also known as my kitchen. Thank you for selecting this video. In today's video, we will be exploring one of the most complex topics for sourdough bakers, and that is trying to identify when is bulk fermentation done. Now, if you're a beginning sourdough baker or even an experienced sourdough baker, this continues to be a challenge. I also struggle with this even today. When I started sourdough baking less than a year ago, I really struggled to find when was bulk fermentation done, and I was having trouble overproofing and underproofing my loaves. And if you're an infrequent baker where you're only baking once a week or once every 2 weeks, it's very difficult to make changes and see the impact on the loaves over time. Some people say that it takes 100 loaves of baking before you really master the ability to look at your dough and determine when bulk fermentation is done. If you're baking once a week, that would take you 2 years. So what we're trying to do here today is to give you some tools, some techniques, and some tips to help you understand how to determine when bulk fermentation is done. Now, some experienced bakers will say that this is something that can't be taught, that it's just something you learn through intuition. I don't believe that. I think that 80% of solving this problem is done through science and observation, and maybe 20% of it is based on experience, but I'm even going to provide some tools today to help accelerate that 20% experiential learning. So in today's experiment, we'll be baking 4 loaves of bread, and what I'll do is I will cut off bulk fermentation intentionally early with one of these loaves so you can see what the dough looks like when it's underproofed. I'll let one of the loaves go longer than it should go so we can see what the dough looks like when it's overproofed. And then we'll have 2 chances in the middle to try to catch that perfect moment where the dough is neither underproofed nor overproofed, but really fully proofed. So I did an experiment similar to this in one of my prior videos where I spaced out the bulk fermentation in 30-minute intervals. And that's an incredibly interesting video that shows what dramatic changes can occur in the loaf with just 30-minute changes in the dough. But it was a fairly narrow range, and all 4 of those loaves came out looking pretty good. So what I'm going to do today as a learning tool is to stretch that time out a little bit more. So we'll be doing 45-minute intervals between cutting off bulk fermentation in these 4 loaves to really give better indications of what a true underproofed and overproofed loaf looks like. And as I said, those 2 shots in the middle to catch it perfectly at the right point. Now, if you're familiar with my experimental videos, I usually go through every step in great detail so that you can replicate the process. In this series of videos, I'm cutting out some of the early steps of mixing the dough so that we can really get down to the fine points of determining when bulk fermentation is done. In all of my videos, I follow the same recipe, the tartine bread basic country loaf recipe. If you're a beginner or if you want to really learn the detailed steps of following that recipe, many of my other videos go through step by step in incredible detail, so I recommend watching those videos first. I also have a number of other videos on bulk fermentation, overproofing, and underproofing. So if you're interested in this topic, search through my video library for other videos on the topic of bulk fermentation. There's a wide variety of content out there. As I mentioned, the recipe that I'll be following today is the basic country loaf recipe from Chad Robertson's Tartine Bread book. This calls for 1,000 grams of flour, split up 90% bread flour, 10% whole wheat flour. For the 90% bread flour, I'm using a blend. So I'm doing a 50-50 blend of that 90%. So 45% of my total flour will be the Central Milling Company organic high mountain, high gluten flour. This is a nice high protein bread flour. And for the other 45%, I'm using Central Milling Company organic artisan baker's craft flour. So that gives me my 90% or 900 grams of bread flour. And then for my 10% whole wheat flour as called for in the recipe, today I'm using King Arthur organic whole wheat, very reliable whole wheat flour that I use in a lot of these recipes. Now, applying the baker's percentage to that 1,000 grams of flour, we use 75% water, so that's 750 grams of water. We mix 700 grams initially. We reserve 50 grams for blending in with the salt. I just use filtered tap water. The recipe calls for 20% leaven. That's 200 grams of leaven. I made the leaven last night. And it calls for 2% salt, which is 20 grams of salt. I use a fine sea salt. So as I mentioned, we'll be following this recipe, and I like to follow it as close to the book as possible. Now, there were a few clarifications that came out after this initial book was published, and I just want to describe those so that we're clear on how I'm counting the timing. In this book, it was ambiguous if there should have been a rest time between adding the salt and the first stretch and fold. In future publications of the recipe, there should be a 30-minute rest after adding the salt before doing the first stretch and fold. So I'll be following that modification from this book. And then this book was also ambiguous in terms of how many stretch and folds should be done. It recommended 4 stretch and folds, and then it was unclear whether you should continue the stretch and folds after the 4th one. Future versions of the recipe indicate that you should be doing 5 or 6 stretch and folds, depending on how the dough feels. We'll probably do 5 stretch and folds at 30-minute intervals in today's experiments. There are also 2 fairly unique things about this recipe. One is that it calls for a fairly warm bulk fermentation temperature of 78 to 82 degrees Fahrenheit. I try to hit that exactly. So I have my oven with the light on, which will heat up to basically the low 80s Fahrenheit. So that range in Celsius is 25.5 to 28 degrees Celsius. I try to run this at about 80 degrees Fahrenheit, 27 degrees Celsius for my bulk fermentation. That's important because the time and the temperature are inextricably linked. So in the recommended bulk fermentation time of 3.5 to 4.5 hours, you have to be in that temperature range for the formula to work per the recipe. The second thing that's unique about this recipe is that it calls for a fairly low percent rise in the dough before you cut off bulk fermentation. This recipe calls for a 20 to 30% rise. Some recipes call for a 50% rise, a doubling of the dough. Part of the reason for that low percent rise is because we're bulk fermenting at a warmer temperature. So what happens here is you're bulk fermenting that dough at 80 degrees Fahrenheit. You let it rise up to, say, 30% when we cut off bulk fermentation. The dough keeps fermenting at a fairly warm temperature. So as you're pre-shaping the dough, bench resting, final shaping, the dough is still fermenting. So that's why in this recipe, you can't let the dough rise, say, 50%, because in that next 30 to 40 minutes while you're doing the shaping and the bench rest, like I said, it keeps going and you could possibly overproof the loaf. When you see recipes calling for a 50% rise in the dough or a doubling in the dough, you'll notice that that's usually when they're recommending doing bulk fermentation at lower temperatures. You can get away with a higher percent rise when bulk fermenting at a lower temperature because there's lower risk of overproofing on the back end of the bulk fermentation. So how do we know when bulk fermentation is done? The first thing I recommend is look at what the recipe says. So this recipe gives us 3 really good indicators of when bulk fermentation is done: temperature, time, and percent rise. So if you're a beginner and you're looking at different sourdough recipes, I strongly recommend finding a recipe that gives guidance on those 3 variables, or at least 2 of the 3. Otherwise, you'll spend a lot of time guessing. So in this example, the Chad Robertson Basic Country Loaf recipe gives us a temperature range of 78 to 82 degrees Fahrenheit. That's 25.5 to 28 degrees Celsius for bulk fermentation. Now that's the internal dough temperature that you want to get at. So you need a thermometer to measure really frequently the internal dough temperature. Some people will just look at what their countertop room temperature is. I also recommend having a countertop thermometer. But my countertop temperature isn't always the same as my dough temperature, particularly early on in the process. So when the recipe gives that range, that means the internal dough temperature should be at that range for the recommended time. The second variable in the recipe is the recommended time. This book recommends 3.5 to 4.5 hours from the time you initially mix the ingredients, the flour, the water, and the starter. We add the salt 30 minutes later. But from that time of the initial mix, 3.5 to 4.5 hours is the recommended range for bulk fermentation time. So make sure that you write down what time you started, what time you added the salt, what time you're doing your stretch and folds. I keep really meticulous records because there's nothing worse than being 2.5 or 3 hours into the bulk fermentation process and you can't remember what time you actually mixed the dough. That's just an easy mistake to correct, so make sure that you keep records of your starting times. And then the third criteria is measuring the percent rise in the dough. Now, when a recipe calls for a percent rise in the dough, that means the percent change in volume of the dough, not necessarily height. And the change in volume will be different from the height if you're not using a straight-sided vessel. So for example, if I try to use this bowl for bulk fermentation, I mix my dough and I put it in here and I say, has the dough risen 20%? There's no way I can accurately tell if this has risen 20% in a bowl like this. Number one, because I can't see through the side of the bowl, it's not transparent, so I really don't have an indication of where I started and where I am. And if I'm just looking down into the bowl, this bowl flares out at the top. So as it's growing in height, it's growing much faster in volume relative to the height because the bowl flares out at the top. So this is a horrible bowl for bulk fermentation. The optimal type of thing that you want to use, and I've used this in some of my experiments, this is a chemistry beaker, perfectly straight-sided vessel. So the height equals the change in volume because the sides are straight, and this has the fine-grained milliliter markers on it which measure the volume of the dough. This might be overkill, so then you could use something like this. It's kind of a household container, not perfectly straight sides on it, but it has the milliliter markers on it, so I can use that. I use this sometimes for my 1,000 grams of flour. Again, this doesn't have straight sides on it, so I can't rely on the change in height, but it has the milliliter markers on the side here, so I can tell the change in volume. That's a good vessel. And then what we'll be using today, when I divide the dough into 4 separate smaller bowls, is I use these bowls. They're transparent, obviously. They're almost straight-sided, but not exactly. So I have to measure the milliliters, and I put markers on this based on measuring the change in volume by adding water to this bowl, and then I make my own marks on that bowl so I can see 10%, 20%, 30% rise off of our starting point. So when you're measuring that percent rise, use the right vessel to do it, preferably a transparent straight-walled vessel or something with the milliliter markers on it. So those are the 3 big variables that you always want to start with: temperature, time, and percent rise. But in addition to that, sourdough bakers develop a feel for other observational criteria. And this is really what I want to focus on today, are some of these less obvious things that you develop through experience. And we're going to try to pull ahead your learning on this, and I'll give you a lot of indications of what are the clues and cues that I look for in 6 other observational variables. The first one is that when we're measuring the dough to see if bulk fermentation is done, you always want to make sure your dough has domed up on the top. If your dough is still flat, that means that there's not enough aeration in the dough, and it's not even really fully into bulk fermentation until you see that doming on the top. The second thing that you want to see is you want to see large bubbles forming on the top of your dough. This usually happens near the end of bulk fermentation, where all that carbon dioxide has pushed up through the dough and it's pushing up that very top membrane of the dough and creating large bubbles on the top. The third thing you want to look for are bubbles on the side of the bowl. So we're going to hold the bowl up and look around the side. And the number of bubbles on the side of the dough is a good indication of the number of bubbles inside the dough. So that gives you a sense of how much aeration is happening in the bowl. And you want to see vigorous bubbles around the edges of the dough. The fourth item is that we're going to do something called the wobble test or the shake test. And this is something that experienced bakers do almost by second nature, and they don't even realize they're doing it. But when you pick up your bowl, you'll see them kind of shake the bowl like this, and you can see the way that the dough starts to wobble on the top of the bowl, or the way that it, what I call splashes. It doesn't really splash, but the way that it moves up against the sides of the bowl. You can really develop a feel for how aerated your dough is by shaking your bowl. You'll see a lot of experienced people do that. We also need to do what's called the window pane test. This ensures that we have enough gluten development in bulk fermentation. In the window pane, we're going to stretch up the dough out of the bowl and try to stretch a super thin translucent membrane that we can see daylight through. That's why it's called the window pane test. And then the last test that we'll do is the smell test. This is another thing that experienced bakers do almost subconsciously. You take your dough out of your proofing chamber, you pull the cover off of it. You might not even see them doing this, but they're smelling the dough as it's coming out of the proofing chamber. I'm going to go like this and really smell it so you can see what I'm doing. And when we smell the dough, what you want to look for is a continuum of underproofed dough, which would be dough that smells like a bag of flour mixed with water. It has that really strong raw flour, just mixed flour and water smell. The other extreme, when your dough is overproofed, is that your dough smells like your starter. That's when it's gone completely too far. What we're looking for through the bulk fermentation process is this continuum where the dough will stop smelling like flour and water, and you'll just start to smell some of the acidity from the fermentation process in your dough. And I'll try to describe that as well as I can. So we have all these criteria that we look for where there's a continuum: no doming, high doming, no bubbles, a lot of bubbles. So if you think of this continuum, what I've done is created a tool for us to use. And this is called the Bulk-O-Matic Bulk Fermentation Completion Indicator System, where I've put each one of these 9 variables, the 3 recipe variables and the other 6 observational variables, onto this chart. And what we'll do at all these checkpoints in bulk fermentation is we'll look at where our dough is on each one of these continuum, and I'll slide these little slider indicators and put this on the screen for you. And what we're trying to do is to get as many of these indicators as possible into this green box in the center, which is the kind of the Goldilocks zone, where it's not too much, it's not too little, it's just right. And when you get many of those variables into that Goldilocks zone in the middle, that's when you know bulk fermentation is done. So we'll go through this example in detail throughout the bulk fermentation process. So now we are ready to mix the dough. In the interest of time, I'll do this off camera. So I have my flour, my water, my leaven. I'll mix this together, and I'm starting that clock at 0 when I mix these 3 ingredients together. At the 30-minute mark, I add the salt and 50 more grams of water. I wait 30 minutes, then I start the stretch and fold process. I'll do 4 stretch and folds at 30-minute intervals. So we'll come back in exactly 2 hours and 30 minutes when I do the 4th stretch and fold. I'm going to snap my fingers and we will move forward in time 2.5 hours. And we're back. That was quick. I get a little lightheaded traveling along the time-space continuum, so I took notes along the way. I mixed the dough, the flour, the water, the leaven, let that sit for 30 minutes. The dough temperature was 81 degrees Fahrenheit, that's 27 degrees Celsius. I waited 30 minutes, added the salt, rested another 30 minutes, then did 4 stretch and folds. So we're on the 4th stretch and fold now, which I just did, and I divided the loaves into these 4 separate bowls. So we're 2.5 hours from the time when we initially mixed the dough. The recommended time is 3.5 to 4.5 hours of bulk fermentation for this recipe. So we're at 2.5 hours. We're still an hour short of the quickest possible time we would expect. The recommended temperature is 78 to 82 degrees Fahrenheit, 25.5 to 28 degrees Celsius. We've been sitting right at 80 degrees Fahrenheit, 27 degrees Celsius. So right in the middle of that range in my proofing chamber, which is my oven with the light on. I'm seeing a little bit of doming in the dough, but not really seeing a percent rise in the dough yet. Now, if you look at this chart for a moment, this is from an experiment that I did a couple of weeks ago with similar recipe at a similar temperature. This was at 82 degrees Fahrenheit, 28 degrees Celsius. And you can see what typically happens here in bulk fermentation. This shows the percent rise cumulatively in those bars, and across the bottom you see 30-minute intervals of time. There's really very little rise in the dough in the first 2 to 2.5 hours. 3 hours in, I saw 1% rise, 4%, 7%. Then look what happens at the end, in this case between 4.5 and 5 hours. It went from a 12% rise in the dough to 25% rise in the dough. So this is typical with bulk fermentation, is you don't see kind of a linear climb from start to finish. You see this very flat curve, and then as it gets towards the end, you see this big inflection point or this big hockey stick where all of a sudden it rises very quickly. That's fairly typical, very much what I'm seeing here today. I don't see a lot of the other variables that we're looking for yet because we're still early in the bulk fermentation process. Let's come back in 30 minutes and we'll assess these against our criteria and see where we are. Okay, we are 3 hours since we mixed the dough. So let's look at our criteria for where we are right now. This is still early, but the first thing we do is take the temperature to make sure that our temperature is still within our target range of 78 to 82. We're at exactly 80 degrees Fahrenheit, that's 27 degrees Celsius, right in the sweet spot of where we should be. So my temperature is within the range. The next thing I look at is the time, 3 hours in versus the range of 3.5 to 4.5 hours, so I'm under on my time. Then I look for my percent rise. I'm still really where I started here. I'm not seeing any percent rise in the dough, so I'm gonna call that 0% rise so far. Is the dough domed up on top? I'd say it's starting to dome up on top, but it's still relatively flat. Are we seeing any bubbles on top? Not really. Are we seeing bubbles on the side? Yes, certainly. So I'd say we have a fair amount of fermentation activity by looking at the bubbles around the side. Then we do the shake test. I'm shaking the dough here. It's not moving very much. That dough is still pretty stiff. Then let's do a window pane test to see where we are in terms of our gluten development. I just grab the dough and stretch it up out of the bowl. That's a fabulous window pane right there. I ripped it at the end. Yeah, that is a gorgeous window pane. Very nice gluten development. You can see daylight through that dough. So we're in good shape in terms of gluten development. It's debatable whether we need to do any more stretching and folding on these loaves. We're 3 hours in, we've done 4 stretch and folds. I'd say let's not do a 5th stretch and fold here, partially because that'll also really help us measure the percent rise. Every time you handle the dough, late in the process, you can start to degas the dough or compress some of the gas out of it. So I really want to be able to measure our percent rise. So no more stretching and folding. We have sufficient gluten development. And the last test is the smell test. This still smells like flour to me. I'm really not smelling any of the acidic smell that comes with later fermentation. This smells nice, but it's just not quite there yet. So all indications are that this dough is still underproofed, which is what you would expect 3 hours in. Let's wait 30 more minutes. We'll come back at 3 hours and 30 minutes. That would be the earliest possible based on the time range that's been given, and we'll reassess these loaves in 30 minutes. Okay, we are 3.5 hours into bulk fermentation. This is the earliest possible that we would call this based on the recommended timing. Let's see where we are. So loaf number 1. So this has been bulk fermenting for 3.5 hours. Let's first check our temperature. 80 degrees, 27 degrees Celsius, right where we want to be, right dead in the middle of that range that's recommended in the recipe. The second thing that we look for is the time. We're at the low end of the range, 3.5 hours against the guidance of 3.5 to 4.5 hours. Then we look for the percent rise. I'm still just not seeing a percent rise in this dough. It's still right at the starting marker. I look to see if it's domed up in the middle. I'd say it's slightly, very slightly domed up in the middle, but not much. Are there bubbles on top? Now I'm just starting to see some small bubbles forming around the edges, but I'm not seeing the big bubbles pushing up through that would indicate that bulk fermentation is done. Bubbles on the sides. I'd say there's a fair amount of bubbles around the sides, so there is some fermentation happening in the dough, but I wouldn't call it vigorous bubbling. I do the shake or the wobble test. The dough still looks pretty stiff to me. It's just not moving very much in the bowl. It's starting to move a little bit more than before, but it's not a loose aerated dough. It's still relatively stiff. We already did the window pane test, so I know we have sufficient gluten development. And my smell test, that's starting to move a little bit away from the pure flour smell. but it's still on the floury side. I wouldn't say that it really has an acidic smell to it, but it's just starting to be what I would call a ripe flour smell, if that makes sense, where it loses that raw flour smell and it starts to get a little bit of the smell of a ripe fruit is the way that some people would describe that. So now let's look at our indicators on our Bulk-O-Matic system for this loaf number 1. Temperature, 80 degrees Fahrenheit, 27 degrees Celsius, right in the range. Time, on the low end of the range, 3.5 hours. Percent rise, still essentially at 0. Is it domed on the top? Very slightly. Are there bubbles on the top? Very, very few. Are there bubbles on the side? I'd say yes, a fair amount, but not what I would expect in a fully fermented loaf. The wobble test still looks fairly stiff. I wouldn't call this loose and aerated. The window pane we already did, strong translucent, so we're good from a gluten development. And the smell is moving slightly to the right of pure floury, but not into what I would call somewhat acidic yet. So this is still all indications this is underproofed. But for the purposes of this experiment and in the interest of science, we're going to show what happens when you cut off bulk fermentation early. So some people might look at this, and this would be a classic beginner's mistake, is I say, my temperature is in the range, 80 degrees Fahrenheit, right where it should be. It's 27 degrees Celsius. My time is in the range, 3.5 to 4.5 hours. I'm at 3.5. So I got 2 out of the 3 key variables. The percent rise, if I hadn't marked my bowl accurately, your eyes will tell you, your brain will tell your eyes that this rose 20% because you have no frame of reference to go off of. So that's the problem a lot of people have, is you don't put an accurate marker on where you started. You can convince yourself of anything. Are there big bubbles on top? No, but there's a few small bubbles. Are there bubbles on the sides? There's a few. I can talk myself into this if I'm inexperienced because I'm hitting, just barely hitting maybe half of these variables where I'm starting to see some movement, and I get impatient and I want to start baking some bread and I say bulk fermentation's done. It's a mistake. I'm doing it against my better judgment, but I want to show you what happens when you pull a loaf too early from bulk fermentation. So now with these loaves, what I'm going to do is something a little bit unique. Normally at this step in the process, we would take this dough out onto an unfloured work surface. We would shape it into a round. That would be the pre-shaping step. Then we would let it bench rest on the countertop for 30 minutes and then do final shaping. When you do pre-shaping and final shaping, you can introduce a lot of irregularity into the crumb. And because with this experiment, what I'm trying to do is really demonstrate the difference in the crumb specifically purely based on bulk fermentation without any influence of shaping. I'm just going to take this dough out of the bowl and put it into the shaping basket without doing any pre-shaping or any final shaping on it. This is almost like putting an X-ray machine on top of the bulk fermented dough right at this point, so you really see what the crumb looks like coming out of bulk fermentation solely based on the amount of proofing that you're doing in bulk fermentation. I've done this before, and this will actually work. Now the trick is to get this out of the bowl without really mauling it and getting it into the basket without losing the little bit of shape that it already has. So I'm going to really carefully move this out of the bowl. Now this dough feels stiff to me. I didn't really do a field test on the Bulk-O-Matic, but if I did, this dough feels stiff. Okay, so there's our dough. You can see it's stiff. It's not drooping out of my hand very much. And I just flop that into our shaping basket. And then the last thing that I like to do when it's in the basket is shake it. And that loaf looks pretty stiff. You can see the way the whole loaf is rocking back and forth in the basket. When you get an overproofed loaf and you shake it like that, you'll see the top portion of the dough really wobbling loosely, but you don't see the whole slab of dough moving in the basket like that. So I'm going to let this now sit for 30 minutes. I'm not going to put it into the refrigerator yet for the overnight cold retard, because normally this would bench rest for 30 minutes between pre-shaping and final shaping. So to be consistent with the recipe, there's still 30 minutes of fermentation going on here. And a lot of people make this mistake. You think that when you decide bulk fermentation is over, the loaf stops fermenting somehow. The yeast doesn't know that bulk fermentation is over. It only knows the temperature. and the internal dough temperature is still 80 degrees, this loaf is still fermenting. It ferments during pre-shaping, it ferments during the bench rest, it ferments during final shaping. So we're going to give this its 30 minutes due on the countertop, then I'll put it in the refrigerator for an overnight cold retard. These will go probably close to 15 hours. The book calls for 8 to 12 hours. You can add extra time onto the cold retard in the refrigerator, and it'll develop more flavor in the dough, but it doesn't really start to overproof the dough once the dough gets down to the refrigerator temperature, and I'll talk about that a little bit later. So I'm going to give this its 30-minute bench rest, then put it into the refrigerator. And now that we've established our baseline with loaf number 1 by pulling this out of bulk fermentation, for loaves 2, 3, and 4, I'm just arbitrarily going to cut those off now at 45-minute intervals. So 45 minutes from now, and we'll still do the test on each one of those so we can see how the variables move over 45-minute intervals. That'll be very instructive, and then we'll bake these and look at the crumb tomorrow with a real specific interval of time, 45 minutes, so you can see the difference across those. It is 4 hours and 15 minutes into our process, so 45 minutes longer than when I cut off loaf number 1. Let's take a look at loaf number 2. Now this one does look a little bit different. The first thing I want to do is take the temperature. This has been in the proofing chamber. This is sitting at 81 degrees Fahrenheit, 27 degrees Celsius, so it's up 1 degree Fahrenheit from the prior loaf. And this one is definitely on the move from a percent rise. This is somewhere between 10 and 15% rise. It's 10% right on the edge of the bowl. It's pretty highly domed up in the middle. Let's call it 10% to be conservative. Is it domed up on the top? Absolutely. Are there bubbles around the sides? Yes, there's an increasing number of bubbles, but it's still not what I would call vigorous bubbling around the sides, but more than we saw in loaf number 1. If I shake the dough in the bowl, this is moving a little bit more than loaf number 1 was. Again, I look at how the dough, what I call splashes up against the sides, and this one has a little bit more movement than loaf number 1, but this is still not a loose aerated dough. Let's do a window pane on this loaf. These all bulk fermented together, so I assume this had sufficient gluten to begin with, but sometimes the window pane will deteriorate as you get towards overproofing. That's a gorgeous window pane right there. It's tearing a little bit quicker than loaf number 1, but I would still call that a very solid window pane. And then the smell test. This is starting to get what I smelled in loaf number 1, what's called this ripe, fruity smell, where you're moving away from a flour smell. It's not quite acidic, but it's getting a little bit of a different fermented note to the smell. So this loaf is, I'd say, starting to move into the range, what we would expect to see a fully proofed loaf, but not quite there. So let's put these statistics into our Bulk-O-Matic supercomputer and see what we end up with here. Temperature 81 degrees, so that's pushing the high end. Time, we're at 4 hours and 15 minutes, so we're starting to push the high end of the temperature of the time range. Percent rise, we're still outside of the range. That's one of the most significant indicators. We're somewhere between 10 and 15%. Now, when you look at the time and temperature, which are starting to push the high end of the range, the thing that you have to remember is that these recipes are formulated based on very strong starter. So when Chad Robertson wrote this book, Chad Robertson doesn't live in a world with weak starters. He lives in a world of super strong starters. So you have to assume that these ranges are at a minimum, assuming that you have a very strong starter. If your starter is a little bit weak, it just might take more time. So that's when I start to see the temperature and the time pushing up towards the right, but the percent rise is still to the left. This just indicates this loaf needs more time. It is domed on top. There are bubbles on the sides, bubbles on the top, one bubble at least, starting to aerate a little bit. Pretty good window pane, and the smell moving out of the floury range towards the acidic range, but not quite there. So this is, as I said, just still to the left side of center, maybe getting into that range, but not quite there. But in the interest of science, we're going to cut off this loaf now 45 minutes after loaf number 1, so we can get a graduated effect of what 45-minute changes in bulk fermentation do to the crumb. So I'll carefully lift this dough out, flop it into our shaping basket. That dough is a little bit looser than loaf number 1, but not much. I'd still call that a fairly stiff loaf. So now if we shake this to me looks a little bit looser than loaf number 1. It's flattened out in the pan a little bit more than loaf number 1, which implies a looser, more aerated dough. I'm going to let this sit on the countertop for 30 minutes now in lieu of its pre-shaping bench rest, and then that'll go into the refrigerator for the overnight cold retard. We'll bake it up tomorrow. Loaf number 3, 5 hours since we initially mixed the ingredients. Let's take a look at what we have here. So the first thing that we want to do is take the temperature. 81 degrees Fahrenheit, 27 degrees Celsius, still right in that middle of the range where we want to be. In terms of the time, now at 5 hours, we're outside of the recommended range of 3.5 to 4.5 hours, so we're starting to push a little bit longer time. But when we look at the percent rise, this one is almost at 20%. This is somewhere between 15 and 20%. That's a little close to call. So we're still slightly below the percent rise. We definitely have doming on the top of this dough. I see a few bubbles around the edges, but I'm still not seeing the large bubbles that I typically would see, but I'm seeing more small bubbles than on the prior loaf. When I look at the outside, I definitely see more activity here on the outside, so that's indication that there's more fermentation and aeration happening on the inside. When I shake the bowl, slightly better than loaf number 2, but I'm still not seeing a real airy, floaty, aerated loaf here. Let's pull a window pane. Really nice feeling dough. It's supple, but it's still holding some strength. That's a really nice window pane. You can definitely see daylight through that. I'm not seeing any gluten deterioration in this loaf, so it's definitely not overproofing. That's still a really strong gluten structure. And then the smell test, it's continuing to move into that ripening smell, but I'm still not smelling acidity. So it's getting there in terms of proofing, but definitely not past the point where it's starting to push overproofing. So this one still seems a little bit left of center to me, partially because of the percent rise, and a few of these other indicators are still left of center. Let's just put the chart up on the screen for comparison. 81 degrees Fahrenheit, 5 hours, roughly say between 15 and 20% rise. Domed on top, few bubbles on top, many bubbles on the sides, not quite loose and aerated, strong translucent window pane, and I'd say a reasonably good smell, not quite acidic yet, so it's just into that green Goldilocks box that we want to be in. So this one's looking pretty good. Let's flip this into the shaping basket. Now this dough feels softer than the other loaves as I'm pulling it out. It's pulling away from the sides a little bit more quickly. And you can see how that's drooping down in my hand a little bit more than the other loaves. So that loaf is definitely softening. And now I do a little shake test. Now that loaf is definitely more aerated. The reason I know that is because when you shake the loaf, I'm not seeing the whole loaf rocking the way that I was with loaf number 1. I'm seeing the top of the loaf really shaking almost separately from the rest of the loaf. That just implies it's a looser loaf, more air in it. That's looking pretty good. That's a pretty loose looking loaf. Now this will bench rest for 30 minutes before going into the refrigerator. Now one of the things to remember is that when these loaves go into the refrigerator, they're still fermenting. This loaf is still fermenting before my eyes. It doesn't know bulk fermentation just ended. It will bulk ferment. It will continue to ferment for 30 minutes here on the bench. Then when it goes into the refrigerator, it continues to ferment. A lot of people believe that when you put a loaf into the refrigerator, it immediately stops fermenting. It does not. Here's a chart. I'll put this up on the screen of a loaf that I did an experiment on a couple of weeks ago, where I put a loaf into the refrigerator and I put a continuous probe thermometer in the dough when it went into the refrigerator to see what the dough temperature does once the loaf goes into the refrigerator. Take a look at this. This loaf went into the refrigerator at 78 degrees Fahrenheit dough temperature, 25 degrees Celsius. It took almost 3.5 to 4 hours for that temperature to get down to 50 degrees Fahrenheit, 10 degrees Celsius. So this loaf is still fermenting in the refrigerator. And then when it gets to 50 degrees Fahrenheit, it's still fermenting, but it slows down. It takes a full 10 hours, if you see here on the chart, for this dough to get down to the refrigerator temperature. So this loaf is fermenting the whole time. I'd say most of the fermentation activity is happening in that first 3 hours when it's above 50 degrees Fahrenheit, 10 degrees Celsius, but it's still going right up until you get down to that roughly 37 degrees Fahrenheit, 3 degrees Celsius, where the yeast production really shuts down. So these will go into the refrigerator with the others, and once they get past that, say 10-hour mark where it's at refrigerator temperature, a few more hours of fermentation on the back end of that does not really impact the crumb in my experience. It impacts the flavor. So these are going to go probably 15 hours before I bake these up in the morning. But that difference between 10 hours and 15 hours, if it's at 37 degrees Fahrenheit, 3 degrees Celsius, there's almost no yeast fermentation happening at that time. It has been 5 hours and 45 minutes since we started the process. Let's take a look at loaf number 4. So loaf number 4, let's check our temperature. 81 degrees Fahrenheit. So all these loaves have sat right at around 80 to 81 degrees Fahrenheit, 27 degrees Celsius, which is right in the range where we wanted to be. Now the time on this loaf is now 5 3/4 hours. So well outside the range, but sometimes you just have to wait for the dough to rise. Let's look at the percent rise. This one's definitely on the move, and this is above 30%. It's definitely domed up on the top. There's vigorous bubble activity around the sides of the bowl, which is what we're looking for. If we shake the bowl, now this is much more aerated than the other ones. You can see the top of the dough is really sloshing around, if I could use that term. There are large bubbles forming on the top. I see one large bubble there, one small one over here. I'm still not seeing the huge bubbles on the top that I sometimes have seen in other loaves, but this has more, I guess, of a large bubble than I've seen on the other ones. Let's do a window pane to see if our gluten structure is still maintained at this long fermentation time. And that feels pretty good. So that still has a really strong, beautiful window pane. Look at that. Just tearing there at the very end. So no indication of overproofing yet on this loaf. Now when I do the smell test on this, this is very aromatic. I mean, this smells very nice. So it's really got that full ripe smell to it. And there's just a hint, a tiny hint of a vinegary smell starting to emerge. So that's actually very nice smelling. It almost has a sweet smell to it. You can almost feel it on your tongue when you take a big whiff of that. So this one is looking the best of the 4. It doesn't look like it's overproofing, even though the time is significantly longer than what the recommended range was. And again, those ranges really depend on the strength of your starter more than anything else, as long as you're keeping the temperature synced up with the time, which we did. We had the temperature right in the range. This loaf just took longer to ferment. It could depend on how strong my starter was when I mixed the leaven. It could depend on how far along the leaven was when I mixed up the loaf. You'll get some variations like this. So let's get this into the shaping basket. Very soft, supple dough. It pulls away from the side of the bowl nicely. It's not sticky like that first loaf was. And you can see that drooping now. So that is a softer loaf. Really nicely aerated. I mean, let me shake this one. Look at how that top is wobbling. That's the wobble that I look for right there. Where the top of the loaf is almost moving independently from the rest of the loaf. that implies that there's a lot of aeration in that dough. This one looks good. Now this will sit on the countertop for 30 minutes, then it'll go into the refrigerator for the overnight cold retard, and we'll bake these up in the morning. Let's just recap the Bulk-O-Matic system for this loaf. 81 degrees Fahrenheit in the range, 5 3/4 hours, slightly above the recommended time. This is at about 30% rise, so it's pushing the high end of the percent rise. So this one's getting up there in terms of as far as we would want to go. It's definitely domed on top. There are a few bubbles on the top. I wouldn't say many. There are a lot of bubbles on the side. It's very loose and aerated looking dough. The window pane is still strong, which is great because that implies there's no gluten deterioration. And the smell is right in that middle range where it's not quite acidic yet, but it's a fruity, ripe smell. So this loaf looks pretty good. This has many more of the indicators in that Goldilocks zone than the others, so I'm optimistic with this loaf. We'll see how it bakes up tomorrow. It is the morning of day 2 and it is time to score and bake the loaves. So the loaves have been resting comfortably in the refrigerator for the last roughly 15 hours. So I put these loaves into the refrigerator at 45-minute intervals, and I'll be taking them out and baking them at 45-minute intervals, so they'll have exactly the same time of the cold retard in the refrigerator. I keep a thermometer with my loaves because it depends what shelf you put your loaves on in the refrigerator. Your temperature may vary. These were at a fairly cold 35 degrees Fahrenheit refrigerator temperature overnight. That's 2 degrees Celsius. Now what I'll be doing with each of these loaves, and I'll do this off camera in the interest of time, is I basically just flip the dough out onto parchment paper. I score it. I don't do any additional shaping. So these are completely untouched since we put them into these shaping baskets. There's no pre-shaping and no final shaping of these loaves because, if you recall, we really want to focus on the impact of bulk fermentation on the crumb, and by doing pre-shaping and final shaping, you can introduce irregularities into the crumb, which we're trying to avoid. So these might not be the best looking loaves in the world because we're not shaping them, but the crumb will be a perfect indication, as if we put an x-ray machine on this loaf coming out of bulk fermentation. So I'm preheating my ovens right now. I preheat the ovens to 500 degrees Fahrenheit, 260 degrees Celsius, with my Dutch oven in the oven with the lid off. So I fully heat up that Dutch oven. Then I put the loaf into the oven with the lid on. I reduce the temperature to 450 degrees Fahrenheit or 232 degrees Celsius. I bake it with the lid on for 20 minutes. Then I remove the lid and continue to bake it at that temperature for another roughly 15 to 17 minutes. So these loaves, because they're relatively small, these will bake up in 35 to 37 minutes. I bake them to an internal dough temperature of 210 degrees Fahrenheit or 100 degrees Celsius. After I bake all the loaves, I'll let them cool, and then we'll assess what they look like on the outside, cut them open, assess the crumb, and then slice them open to see the impact of bulk fermentation on the crumb. The loaves have baked and cooled for 90 minutes. So before we cut into the loaves, let's look at what they look like on the outside. The first thing that really jumps out at me is these loaves just look spectacular for loaves with no pre-shaping and no final shaping. I mean, just look at this loaf number 4. I mean, look at the ear, look at the oven spring, look at the symmetry of that loaf. It's really incredible that that's really just bulk fermented dough that we put into a shaping basket. So I didn't do anything to this loaf other than mix the dough, and then I let gravity essentially shape the loaf in the shaping basket. This is how Sir Isaac Newton would have shaped his sourdough loaves. He would have let gravity do the work. That's all we did. It's pretty amazing. And what this really emphasizes is that the vast majority of what you get in your final loaf comes out of bulk fermentation. Pre-shaping is overrated. Final shaping is overrated. If you really bulk ferment your dough perfectly, you get 90% of the final loaf coming out of bulk fermentation. It's really quite extraordinary. So let's look at the loaves from left to right. So just as a reminder, some of the vital statistics on these. Loaf number 1, this one bulk fermented for 3.5 hours. Loaf number 2, 4 hours and 15 minutes. Loaf number 3, 5 hours. Loaf number 4, 5 hours and 45 minutes. That was against the recommended range of 3.5 to 4.5 hours. So these first two loaves were kind of within the window of the recommended range. Loaves 3 and 4 pushed outside of the range. But the problem that we saw is that we just had a slow percent rise on this dough, where loaf number 1 had 0% rise when we cut this off. Loaf number 2 had somewhere between 10 and 15% rise. Loaf number 3 just barely had 20% rise. And loaf number 4 had 30% rise in the dough. So our timing pushed a little bit far on the loaves to the right, but that's when we really got up to the maximum, that 30%, which is the top end of the recommended range in terms of the percent rise in the dough. So now we know when we pulled each one of these out of bulk fermentation, but if you were really an expert bread reader, there are also some indicators here of whether these are underproofed or overproofed, and I'll try to point those out to you. On loaf number 1, this is basically our presumably underproofed loaf, because all of our indicators were left of center on the Bulk-O-Matic system that would imply that this loaf is underproofed, and I see some indicators here in the loaf. If I hold this up where you can see that a little bit better, what you see is that this loaf is very flat on the ends, so that just implies that the loaf is fairly dense, and then it's more pyramidal in shape. It's almost like pointing up, almost like a triangle. That implies that the loaf is dense, which gives you these flat ends, and that there was gas bubbles released during the oven spring part of the baking process from under fermented dough that causes this high spot in the middle. So when you see a pyramid or triangular shape, that's an indication typically of underproofing. Loaf number 2, which was also left of center on the Bulk-O-Matic indicator, this one has the telltale sign of a big belly or a bulge. If you look at the top of that loaf, you see that big bulge right here. That is basically a gas bubble that occurs from underproofing. This is the type of loaf that I call false hope, where you see this come out of the oven and you think, oh my gosh, this has spectacular oven spring. But then when you cut this open, what you'll typically see right there is where I see that bubble. I can see it really clearly. That's probably a big gas bubble from underproofing. Loaves 3 and 4 look pretty good to me. They look like they're in the possibility of well-proofed loaves. And loaf number 4 might be pushing a little bit of overproofing, because if you look at this one from the top down, you can see that that loaf is starting to spread out. It's getting a little bit wide around the waistline, if you will. So when I look at that loaf, I'm saying that is right on the edge of losing some of its gluten strength. And this was the one that we pushed 5 hours and 45 minutes against the guidance of 4.5 hours. So this could theoretically be pushing a little bit of overproofing, but that is not looking like a horribly overproofed loaf. It's just moving in that direction. Loaf number 3 looks pretty good. I'm not seeing any of the telltale signs of underproofing on the outside of the loaf, and I'm not seeing as much of the relaxation from possible overproofing on number 4. So I think our best shot here at a really nicely proofed loaf is probably loaf number 3 or loaf number 4. I can't really tell the difference from the outside. So without further ado, let's cut these open and see what they look like on the inside. Now let's cut into these loaves and see what the crumb tells us about how far we went with bulk fermentation and whether it was sufficient or not. That's really the only way to tell, is to cut the loaves open, and we'll see if the crumb confirms our hypotheses about where these fell on the bulk fermentation continuum using our 9 indicators. So loaf number 1, as I mentioned, kind of flat ends, didn't rise very much, and it has that pyramidal shape, implies that it's underproofed, and all the indicators from our assessment criteria would imply underproofing. And there it is. That's a classic underproofed loaf right there. The 2 things that really jump out immediately is, see this dense crumb right along the bottom. That is a classic indication of underproofing, is that row of dense crumb right there. And the second thing are these tunnels. That tunneling is basically under-fermented yeast that gets a last gasp of activity in the oven. So this is not horribly underproofed. This was on the low end of the range in terms of time and temperature, 3.5 hours, which was possible, but the percent rise was 0. and we were looking for 20 to 30% rise. So this loaf was fermenting. Clearly, we saw that through some of the bubble activity, but it didn't get the percent rise that we needed to fully ferment. That's a classic underproofed loaf. Here's a more detailed view of the crumb. You can pause the video if you would like to assess this in more detail. And here are the 9 assessment criteria that we used for this loaf to determine whether bulk fermentation was done. Loaf number 2 was within the range in terms of time and temperature, so this bulk fermented at 81 degrees for 4 hours and 15 minutes against the guidance on the high end of 4.5 hours, but we didn't see this hit the percent rise that we were targeting. This only rose between 10 and 15% versus the low end guidance of 20%, and I see this bulge here, or this belly, which I'm still a little bit concerned about. We'll see if that's a gas bubble caused by underfermentation. Loaf number 2. Now this one is slightly better than loaf number 1, but it still has these telltale indicators. This strip of the dense crumb right at the bottom there, I see it again here, and we still have our tunneling here, and that one is our gas bubble that caused the belly right there. If we cut further into that loaf, you'll see more of that. So again, this one actually has decent oven spring, has a relatively nice shape to the loaf. I would call this just very slightly underproofed. You can take a closer look at this one in detail, but this is classic slight underproofing in my opinion. Here's a more detailed view of the crumb. You can pause the video if you would like to assess this in more detail. And here are the 9 assessment criteria that we used for this loaf to determine whether bulk fermentation was done. Loaf number 3, now this was really the first loaf where we had the majority of the assessment criteria in that range, in that Goldilocks box in the middle of the Bulk-O-Matic system that shows that this loaf should be closer to being fully proofed. It was a little bit under still in terms of the percent rise. This one was just barely at 20%. It was between 15 and 20, but all the other indicators were that this one was in the range of being fully proofed, but maybe slightly under. Now that's a nicely proofed loaf. It doesn't have the indicators of underproofing as badly as loaves 1 and 2. I still see a very small strip of dense crumb here at the bottom. I see one tunnel here. So we're moving along this continuum of better and better proofing of each one of these loaves. This one's still a touch under, which would not be a surprise because we didn't hit that 20% rise. This was still somewhere between 15 and 20%, and that really is proving to be the most critical criteria in these loaves, is that percent rise of the dough. So let's take a closer look at this one. This one, as I said, it's improving, but not quite there. Here's a more detailed view of the crumb. You can pause the video if you would like to assess this in more detail. And here are the 9 assessment criteria that we used for this loaf to determine whether bulk fermentation was done. And then loaf number 4. This loaf really looked the best in terms of the indicators on the Bulk-O-Matic indicator chart. This one had the 30% rise that we were looking for. So of all the 4 loaves, this is the only one that was really in the range of the target percent rise. Some of the criteria were starting to push a little bit towards overproofing, but the vast majority of them were right in that sweet spot. Now loaf number 4, this is really the best looking one of the 4. This is more fully proofed than any of the other 3 for certain. You just see much better shape of the loaf. There's more air in the loaf across the board. I don't see that dense ridge here on the bottom. This one started to proof more closely to the bottom. I still see a little bit of density on the bottom of that one. And I'm still seeing a little bit of tunneling here on the top. So this is clearly the best of the 4. We just hit that 30% rise mark in this one, which was the high end of the range. So I'm a little bit surprised that this is still under. So this is a very nicely proofed loaf, but still not exactly where I would want it to be. This could have gone a little bit longer. Here's a more detailed view of the crumb. You can pause the video if you would like to assess this in more detail. And here are the 9 assessment criteria that we used for this loaf to determine whether bulk fermentation was done. But one of the things that I've learned in all these experiments is that the bisection of the loaf doesn't tell the whole story. We have to go into these loaves a little bit deeper. So now let me slice all 4 of these loaves and let's take a deeper look into what's actually going on. So now what I've done is I've sliced all of the loaves and I have 5 slices from each loaf, loaf number 1, loaf number 2, loaf number 3, and loaf number 4, for a little bit deeper analysis of what happened. And based on my prior experience, what I'm also seeing here is that this tells a little bit better story than just that bisection cut. What I see here is that loaf 1 actually looks a little worse than it did in the bisection. Super dense crumb around certain areas of this loaf, and then that tunneling went deeper than was indicated in the bisection. And then loaf number 4 actually looks significantly better than it did in the bisection. I think loaf 4 actually looks fully proofed to me. That first cut down the middle had that 1 air bubble in it, but when I look at this now, 4 is a much more fully proofed loaf than was earlier indicated. So now let's go through these again one at a time. 45 minutes difference between each one of these loaves. The percent rise in the dough was really the indicator of what was going on because the temperature was exactly the same on all of these, 81 degrees Fahrenheit, 27 degrees Celsius. 0% rise in loaf number 1, roughly 10% rise in loaf number 2, between 15 and 20% rise in loaf number 3, and then the 30% rise in loaf number 4. That percent rise is really the dominant variable that explains a lot of the differences here. And then those supplemental factors that we looked for, the bubbles on the top, the bubbles on the side, the doming on the top, those give you the confidence of whether to cut off bulk fermentation solely based on the percent rise or not. So when you look at 30% alone, you may not be confident to say whether that's done, but if you look at a 30% rise with all those other indicators that we saw, which were in our target range, our Goldilocks zone, number 4 looks better to me here than it did through the initial cut and is more consistent with what we saw in the Bulk-O-Matic assessment. Loaf number 1 is what you would expect, classic under fermentation. Loaf number 2, this is sometimes called a fool's crumb. And again, we saw that big belly. Here's the hole that caused that belly on the top. I could tell that from the outside. You see these big holes here, but it's really due to under fermentation more than anything else. That's not a true open crumb. That's really a false open crumb. Loaf number 3 is just kind of a okay, starting to be fully proofed loaf. That was at our roughly slightly less than 20% rise against the guidance of 20 to 30. That's about what you would expect, maybe slightly under because we were just on that left side of the range. And then loaf number 4 looking more fully proofed. And then just to revisit the topic of pre-shaping and final shaping, I mentioned that pre-shaping and final shaping are overrated because this loaf, for example, looks better than some of my loaves that have been pre-shaped and final shaped. You can do more harm than good sometimes with the shaping, but also one of the benefits of pre-shaping and final shaping is that it redistributes the crumb. So a loaf like number 3, where we had, kind of some dense areas here and some open areas elsewhere, those actually could even themselves out a little bit when you do the pre-shaping and final shaping. So what we're seeing here is really the most raw version of the crumb that's just as it came out of bulk fermentation. The last time I handled this was on the 4th stretch and fold, other than when I flopped this into the shaping basket. When you make this into a round, you fold it over, that's reorganizing the crumb, and that'll even out some of these irregularities in the crumb if you're really good at shaping. I find that for me, it's a mixed bag. Sometimes I could take loaf number 4, really beautiful uniformity of that crumb, and my pre-shaping and final shaping might actually make that worse. So it's a little bit of a toss-up as to whether shaping improves or deteriorates the look of your crumb, but it definitely is important to be aware that the shaping can change the way that your crumb looks, sometimes better, sometimes worse. So I just did a taste test of these 4 loaves, and interestingly, you can really taste the loaves get more sour as you go from loaf number 1 to loaf number 4. And some people say that the only way you develop that sour flavor is by doing an overnight cold retard. You're building up that sour flavor even through the bulk fermentation process. And when you have a fully proofed loaf, you're building that baseline of the sour flavor that comes from bulk fermentation. When I tasted these, loaf number 1 was really uninteresting. It kind of tasted like water and flour. If I didn't know this was a sourdough loaf, I tasted very little, if any, of the sour flavor in that. In loaf number 2, I started to taste more of a wheat forward flavor with a little bit of the sour enhancing that wheat flavor. In loaf number 3, this is where there was a big step up in the sourness, and I immediately felt that salivation in the back of the tongue when you really bite into a sourdough loaf. That became evident in loaf number 3, and loaf number 4 was even more pronounced, with the interesting thing about loaf number 4 is that the texture of the crumb influences how you taste it and the mouthfeel of the bread. So, some people say, what's the big deal about having, all these holes in your crumb? It changes the way you taste the bread because you're getting more aeration as you're chewing that bread than you would if you ate a very dense piece like that one. So what is the moral of the story? Time matters. Patience matters. Look at these 2 loaves. Loaf number 1 versus loaf number 4. The only difference in these 2 loaves was 2 hours and 15 minutes. They were exactly the same batch of dough, the exact same recipe, the same hydration, same number of stretches and folds, no pre-shaping, no final shaping. They went the exact same amount of time for the overnight cold retard in the refrigerator. The only difference was I didn't touch this loaf for 2 hours and 15 minutes after I touched loaf number 1. The baker doesn't make the bread. The yeast makes the bread. The lactic acid bacteria makes the bread. The formula, the recipe makes the bread. The clock makes the bread. This is the classic example of why bulk fermentation matters so much. People will beat themselves up when they make loaves like this. They'll change the recipe. They'll change the hydration. They'll do more stretch and folds. They'll say, my shaping was horrible. My shaping caused all these problems. None of those things caused this to happen. All we did was cut the time too short, because this is the exact same batch of dough, and that bread looks beautiful. So what I recommend is, if you're struggling with underproofing, which this is a good example of the impact of time on underproofing, the next time you bake, don't change anything. Don't change your flour, don't change your hydration level, don't change the recipe. Just add 30 minutes of bulk fermentation time. And the next time you bake, add 30 more minutes. And the next time you bake, add 30 more minutes until you find that sweet spot. The worst case is you'll go over time one time by 30 minutes and you'll slightly overproof a loaf, but then you'll know exactly where that cutoff point is. And if you keep accurate records of what your dough looked like, what it felt like, what it smelled like, when you hit that sweet spot, you can replicate this time and time again. I hope you found this video helpful. I certainly enjoyed this experiment, and I look forward to more experiments along my sourdough journey. Good luck with your sourdough journey as well.